Hi all and welcome back to the channel. Here we're going to have a look at some of the fundamental concepts in Solidity, and today it is enums. Now, enums are really useful, and we're going to begin as always with what exactly is an enum. An enum is an enumerated list. It is a user-defined variable which can have a given amount of predefined values that are set out when the structure of the enum is defined. So it's often useful to think, why do we use enums? Enums are really useful when we want to demonstrate a given state for a smart contract, or we want to use other scenarios where there's a limited number of options which a variable can be. So a great example is if we have a state, it might be on, off, or loading. We might have another state where a contract is delivered. So it might be we might start off in pending. We might um, then transition to out for shipment, or then we might also transition into cancelled. So as always, we're going to jump into the code, and all of this will become clear when we see enums in action. All right, now that we're actually in our Remix IDE, we're going to jump in and see enums in action. For those who don't know, Remix is a free online IDE which allows you to get some of your blockchain ideas down before you actually transition to another development environment, such as something more conventional like Visual Studio. Anyway, to begin with enums, we begin by using the enum keyword, all lowercase, and then we give our enum a name. So for this, we are going to use the name state, and here's where we actually define all the different states this particular enum can have. So we're going to have one called on, we're going to have one called off, and one called pending. So this will be quite a typical example. So to actually initiate an enum, we first use our enum type here, which we declared just a moment ago. I'm going to call this particular instance enum just state underscore. Now that's actually our enum defined, and we can see this compiles without any errors. But what we want to do now is actually see what the state of the enum is. So for this, we're going to create a function called enum. It's not going to have any input. It's going to be a public function, which means it's accessible to anyone once it's deployed. It's going to be a view function. It's going to return an enum, so this particular enum that we defined up here. And for this, we're going to have it return state, which is this instance of the enum. So an enum can only be in one particular state at a time, and we're going to actually see now once we actually deploy this to the blockchain. So that has successfully deployed. We're going to see, we can see our function here, and at the moment it's returning 0, which is as expected, because by default our enum will be on the first member that we define. So in this case is on. But if we had off defined here first, this would be in that state as well. So when you're actually getting the state, it returns as a uint, and this uint corresponds to what this is. So to illustrate my point further, I'm going to create a second function which is called set to off. Again, this is going to have no input. It's going to be a public function, and it's not going to return anything. So all it does is essentially get our state enum and set it to off. Now if we save this, no error, so we're going to delete this instance of the contract and we're going to deploy our new one. And when you see our view enum function, as per per usual, it returns 0. But if we set it to off, this function successfully executed. But now if we have a look at our view enum function again, this becomes 1. So it's very similar if we set our state to pending, the exact same thing will happen. So we're going to delete this instance of the contract and we're going to deploy it. So in the first instance it's 0, then this function, once we engage it, our enum now returns 2, which correlates to pending. Okay, so that's really cool. Now, one of the really useful features of enum is that allows us to do some conditions. So for example, we have this function called foo, and this function isn't going to actually do anything, but we're going to throw in our requirement. So we use the require keywords followed by brackets, and we want our state, the enum we defined earlier, equal to state dot off. So we're getting a compilation error here. Okay, that works. And now if we save this, we're going to delete this contract instance. We're going to redeploy it. We see view enum and foo. Now let's see what happens when we actually try and call the foo function. It won't run, essentially because we have it that for the function to run, the state needs to be in off. And obviously it's not in off, but if we were to save this to on, we're going to redeploy the contract, create another instance of it, and now you can see the foo function works perfectly. So that's pretty much it. As you can see, enums are a great way of saving different states and keeping a track of a given state in our applications, in our smart contracts, and it's really useful if we want to make sure that certain functionality doesn't happen unless the contract's in a given state, and that's where enums really come into their own. That's pretty much it, guys. Thank you very much for watching, and be sure to smash that like button and subscribe to the channel if you're enjoying this new content. I'm going to try and keep on delivering as much as I can for you guys. So thank you very much, and until the next time.